video, we're going to return to Berkshire Hathaway. We're going to look again at the composite model. And we're going to try and study the type of risk diversification credit you get by writing multiple lines of business. So here's the composite data set. We're going to run the model.goodnew. And what we'll do is forecast. We're going to load. We're going to load our good new combined. Load. Okay. All right. Now, I think I want to run the model again. Let's run the model again. So we can go back to, or we can load it from here. Load model in new module. So let's load it again. We can then forecast for each. It's the same model. In the first one, we'll load good new combined. But in the second one, we'll just do a forecast for OEA. You might remember that OEA had the largest capital allocation. So what I'll do is I'm going to load good new combined, but I'm going to remove, I'm going to use my shift key. I only want to keep OEA, so I'm going to remove the others. I'm going to save this as, say, good new combined OEA only, say. So we're only doing the forecast for OEA. Okay, and let's open both forecast summaries and so on. Okay, so here we have the forecast for OEA, and over here we've got the forecast for the aggregate. And let's see the kind of capital allocation. So we'll do both simulations just for the reserve to find the capital allocation of various VAR percentiles. So we'll just do it for the reserve. And why don't we just stick to 1,000 simulations, given that we're using the kernel as an estimate to the sample values. Shouldn't make too much difference to the answers in the reserve here. And now, tile vertically, minimize other types, and let's look at the risk capital graphs. That's just for OEA on its own. And that's including OEA. So for instance, the total risk capital for OEA, if that's the only line you wrote, right? Let's make it the 95th percentile. 95th percentile here is 2.8 billion. That's if you only wrote OEA on its own. At the 95th percentile, you would need 2.8 billion. What is the mean? Let's look at these two. The mean is 3.78 billion. The risk capital is 2.8 billion. That's a large proportion of the mean. Okay? Now that you're writing OEA with other lines of business, the total risk capital for the aggregate of all the lines is 3.73 billion, but how much do you allocate to OEA? Let's just find OEA. Remember, OEA is the largest. The fact that these letters sort of cross each other, overlap each other, that's going to be fixed up by the time we release 10.4, and we're going to have the labeling at 45 degrees. Okay? Now, how much capital are we? Well, now we're assigning 2.086 billion relative to 2.8 billion. So if you write OEA and the other lines of business, the risk capital assignment to OEA is considerably less. It's almost less by almost a third than if you're just writing it on its own. And that's very important. Okay? If you did it for you did it for, say, the combined, we can do also simulation for the combined for each. Well, let's just do it future. That's the underwriting risk. Future, by future we mean future underwriting years or accident years. And let's do this one, the future also. So now we find that the total, in fact, the risk capital for REA, it's huge. I mean, it's well above the mean. It's 9.7 billion, whereas here, the risk capital for REA is 5.3. Well, it's 5.3 billion, much less, much less. You know, a lot of risk capital REA, it's got a lot of volatility. You might remember it has a lot of process variability. So it's much less when you write down the line of business. So essentially, not correlated. Remember, if we look at the forecast summary and we look at the reserve distribution correlations, what's the that's not reserved by data sets. Correlations, it's 0.19. That's 0.07. Do we find anything larger than 0.19? I don't think so. So you get a lot of credit diversification by writing the other lines that are essentially independent. Okay, why don't we close one of the regressions, like the second one, so we don't have to have two runs of the same model. Why don't I just estimate the model again so we get rid of a lot of the pictures? I got a logbook and just run the model again. And what I'm going to do now is actually simulate a composite data set from the model. Let's revise the model. The model has a trend structure and volatility about the trend structure for each line of business. For instance, REA has a lot of volatility. Let's look at that. REA, process variability, the standard deviation of the normal exceeds 0.6. Other lines of business like MMCM, medical malpractice, claims made, has got a standard deviation of, well, much less, 0.11. Workers' comp, has got a standard deviation, well, it goes up to quite high. It's got quite a bit of volatility. Remember, we do require quite a bit of risk capital for workers' comp as a proportion of the mean. Okay, let's simulate. So we're going to simulate from these trend structures, the volatility around trend structure normally distributed, and the correlations, when there are very few of those correlations. Very few are in fact significant. Most you can see are zero. Okay? So we go to test. We go to simulate composite. We'll only simulate one composite data set. What it's going to do is it will simulate a data set or a triangle for each line of business, assign that or put it, insert it in each one of the triangle groups, and then create the composite data set in the composite triangle group. Let's do that. So that might take a few seconds. Okay, so let's see what it's done. If we go back to the triangle group, the composite one, and we go to triangle groups, you'll see that if we open one of the triangle groups, there's a new simulated data set called PLI Sim1. If I close this triangle group and go back to my composite data sets, there's a new one called CDSS Sim1, which is, if I click on it, is each of the simulated ones from each one of these lines of business. If I go to models, and there aren't any composite models. However, I do have already a model which we call good new, a composite model, which will drop onto the simulated composite data set. And not only that, we also have a forecast scenario going forward from the real composite data set. Let's go to forecast. And our forecast scenario we called good new combined. Let's copy that also onto the simulated composite data set. So now we can go to the simulated composite data set, go to models and run the same model, and we can do a comparison of the model displays. They're not going to be identical, but statistically they will be the same. So that's homeowners, farm owners, the trend structure, not exactly the same trends. No, that wasn't homeowners, farm owners. Let's click there. That looked a bit different. Okay, homeowners, farm owners, that's minus 63, minus 71. Well, if you consider standard deviation of 3% there, 3% there, that's not too bad. PPA, PPA. Let's now check the calendar year trends. Okay, Cal, very similar trend structure, workers' comp, and so on. Let's now do a forecast for each. Load, new combined. That's the obviously the simulated composite. And then we're going to load it for the real composite, the real data. And then we're going to check out the forecast summaries. And statistically, they should be the same. In other words, the model does replicate the features in the real data. So this is the real data, and this is the simulated one. 22.69 billion versus 23.89 billion. Coefficient of variation 8%, 9%. Let's go to other lines of business. HLFO, 9, 10. Of course, weather CV, whether it might be some large differences is where the coefficient of variations are pretty large. The coefficient of variation each side is 24%, 24%. The numbers are pretty close to each other. Okay, 9 point, if you look at this row and you look at this row. If we go, say, to workers' comp, that had a reasonably high coefficient of variation, maybe there we might, if we're unlucky, find some major differences. And we do, you can see that. 47% coefficient of variation, 51%, 1.27 billion versus 971 billion. But that's quite okay because you've got a lot of process variability in that line of business. If you go to Cal versus Cal, presumably that's going to be closer. Oops. Yep, that's much closer. What about OEA? I mean, my guess is that OEA would be quite far away. That's got a huge coefficient of variation. Let's see what's there. And you simulate another sample from a lot of process variability. Oh, that's remarkably close, isn't it? 40%, 41%. I guess that's just by luck. Similar standard deviations and similar means. What if we now just run for each triangle, for each composite data set, for each line of business, we run the starting model, which is called single gamma model with inflation. In other words, one parameter in each direction. And we do the same thing for the other. And now we just look at the residual structures and see if they are similar. So let's go to workers HLF on this side. And on this side also HLFO. And do they look similar or very different? Well, to me they look pretty similar. There's a bit of a drop here. I guess that's a little bit different, but we don't have that drop there. Let's look at PPA versus PPA. Pretty similar. Look at those two. If you look at Cal versus Cal, I guess what I'm trying to point out is that it's very hard to distinguish between the real data and the simulated. Now, workers' comp could be quite different, and I guess for that is there's obviously an outlier here, so it's hard to tell. What about if we look at workers' comp versus calendar years? I guess you'll see it's more similar. I can always remove that outlier just to see how it looks. There's another one there, unfortunately. But they look a bit the same. Yeah, they look a little bit more the same. CMP, C and P, the other directions, and so on. Anyway, these ideas have been illustrated in other studies. Okay, so we found out that you get a lot of credit, diversification credit, for writing multiple lines of business. Long tail lines of business very often are not correlated, they don't have any process correlation, and very often, but most of the time, I mean, for most of what we've studied and we've seen, they don't share a common trend structure, and therefore they don't have the same drivers in particular in the calendar years. So you get a lot of credit diversification if you write multiple lines of business. We also saw in the, I guess in the previous study, that the combined risk charge should be less, and sometimes quite a bit materially less, than the risk charge for reserve plus the risk charge, the sum of two risk charges for reserve and underwriting risk. Thank you.